Welcome. Now I am going to discuss on that next name reactions related to carbohydrates. This is semi-pinacolone rearrangements. The previous class I have discussed about of that pinacolone rearrangements. So what is the difference between the pinacolone rearrangement and pinacolone rearrangements? So if I talk here about of that semi-pinacolones, colon rearrangements, and here pinacolone rearrangements. So what is that? In pinacolone rearrangements, what we see that two carbons are there, that I have already discussed. Here OH will be there, means adjacent to two carbon atoms, two OH group will be there, and here some groups are there. Okay, and here we will do that acidic mediums. This is the setup for the pinacolone rearrangements. And what here the important things is that which OH group will be protonate. This is the acid, so which OH will protonate, that also you have to decide, and that OH will be protonate which give that stable carbohydrates, means most stable carbohydrates. Okay, let's say here we have that CH3, here CH3, and let's say here pH is there, then this will do the protonations. So that I have already discussed that. Here what we see that two carbon atoms, at the two carbon atoms, two adjacent carbon atoms, two OH will be there, and that OH will be do protonates which have that stable carbohydrates, which after this OH do become a living groups and it leaves, that carbohydrates should be stable without any rearrangement. That is the pinacolone rearrangement, and that condition should be acidic medium. This is the about of the pinacolone rearrangement. And what is the for semi-pinacolone rearrangement? Here what we have that two carbon is there, and unlike pinacolone rearrangements, here one OH will be there at one carbon atoms, and adjacent to this carbon atoms, what it will be there here, that instead of OH some other groups are there, like NH2 is there, if suppose, then the reagents here that given here, no need to be acidic mediums, here that reagent should be that like HNO2. You know that HNO2, it will make this NH2 nitrogen gas, and this will remove. Okay, so this is that setup for the semi-pinacolone rearrangement. Okay, so it means that two adjacent carbon atoms, one carbon have OH and other carbon have NH2, or maybe like you have that, suppose here we have that carbon and carbons, and let's say here always OH will be there, and here suppose you have that chlorine atoms, and then here that reagent should be that AgNO3, such that this group will be removed as a living groups. Okay, because this will share with that, and after that it will leave. It means that in semi-pinacolone rearrangements, that one will be the OH and other will be the some other groups, with that reagent will given such that this group will be leave. Okay, so unlike pinacolone rearrangement, where we have to decide that in between two OH which will be do protonates, and that OH will protonate which will give stable carbohydrate. But here in semi-pinacolone rearrangements, that groups that has to be leave, and such that that has to be leave, that's why some reagent will given so that that will leave. Means here nothing like we have to look that this OH will be leave, that type of things here not there. Okay, here but you see that NH2, this group has to leave, for that type of reagent is given. So that is the things is present in case of semi-pinacolone rearrangement. Okay, so this is the about of the semi-pinacolone rearrangement. So here the setup will be two carbon atoms and two adjacent carbon atoms. Two carbon atoms will be there, they are adjacent, and one will be OH, and other to this carbon atoms where OH is attached, adjacent to that carbon, that NH2 either Cl is there, such that this group will leave, always this will leave. Okay, so this OH will be not leave. So here this OH will have that no role in leaving group, so this will not leave, always this will be leave. Okay, so that is about of the semi-pinacolone rearrangements. So what we will see that we will look the examples and we will clear more about of this name reactions, that is semi-Pinacolone rearrangement. So first example is if I says this is that PHCH3 and OH is there and this is there. Okay. So now this HNO2 we know that chain of rearrangement. What we see that whenever this is there, then this always make this nitrogen gas and it will leave N2 gas. NH2 will not leave, it will make this one into N2 gas and then it will leave. Okay, that we have discussed already. So what we will get here, PHC and CH3. Note that this OH will not never leave. Okay, only always this other group will leave. So this and this H and this is CH3 and here we have that positive charge. So now what we will do that here, that this will shift. So we know that migratory aptitudes first will be that phenyls, first is hydrogen, then phenyl, then alkyl group. So here hydrogen not there, so phenyl will shift. So what we get here, CH3 and here OH, then here we have positive charge, then here we have that H and CH3 and here we have that phenyl. Now what will happen that this have the lone pair, so it will share it. So what we'll get now, this is going to be the double bond of O, because that we know that. So this is going to become whenever this lone pair will go here, then this will get positive charge and this hydrogen will go. That's why this become this one. I'm making directly CO this, or I can make for this I'm making, other I will not make. So this become like this and this O and here H and this is going to be positive charge and this is going to be that CH and this is going to be CS3 and this is going to be that pH. Okay, so now what will happen, this will leave here, then we will get that C double bond of O and here CS3 and here C, here H, here CS3 and here pH. So this is the final answers for this question. So likewise we will solve the questions. Moving to that next examples, here also same things that I said that okay, either here chlorine halogen atoms is there or amine is there. If amine is there, then HNO2 will be there, such that this group will leave. Okay, so now this is there, so this is AgNO3 means this is Ag plus and this is the Lewis acid. Okay, so it need electrons, so this Ag plus and it have the lone pair electrons, so this will share here. So with that AgI will leave here. Okay, so what we'll get now, this is here we have that CS3, here CS3 and here we have that OH and this is going to be the CS3 and this is going to be the CS3 and this is going to be the positive charge. Okay, now what will happen that alkyl will shift, so that we are going to get here CS3, here we have that positive charge OH and this is going to be the CS3 and this is going to be the CS3 and this is going to be the CS3. So now this lone pair will give electrons here, so that we're going to be C double bond of O, this is going to be CS3 and this is going to be the CS3. So this is the final product for this questions. So likewise the same procedure will follow as like Pinacolone rearrangement, except that here what will that we will not need to give any acidic mediums, that the reagent will be there, that will take that. After that same rearrangement will occur as like Pinacolone rearrangement, means that alkyl shift, that the same things will occur. Okay, now moving to that last examples for this semi-Pinacolone rearrangements. So what we have seen that whenever that order of reactions, not this order of reactions, order of rate for protonations. If you want to do the protonations, it means that here, okay, this will do the protonations. So if acid is there, for that this will do the protonations, or this also can do the protonations. So if the order of rate of protonations, it means that acid group is there. On that case, what it will prepare? First 3 degree, then 2 degree, then 1 degree. It means that this carbon is 3 degree and this is the 1 degree. So which will do the protonations? So this will do the protonations. Okay, this is the one. And secondly, if TSCl is there, that I can say that order of rate of TSCl and pyridine is there, then what happened? That 1 degree, then 2 degree, then 3 degree. So if this is given, then the order will be the 1 degree, then 2 degree, 3 degree. So for this, what is seen that this questions. Okay, if we have that H plus, and here we have that PSCl and pyridines. Okay, so what you see here, that if it is H plus, then that this is the protonation. So protonations, this will not do protonations, this will do. Okay, this will do, this will not do. Okay, so when a protonations, that is 3 degree, then 2 degree, then 1 degree. That is for protonations. So if acid is there, protonations, for that case, what we get the product? So that product is, so here we have that OH lone pair attack, so that is going to be here positive charge, and it is going to be that OH. Okay, so now what will happen, that this will leave here minus water, so that we are going to get, here we have that positive charge, and this is going to be the OH. Okay, now what will happen, that these carbon atoms, so this is actually this example is for that Pinacolone rearrangements. Pinacolone rearrangements. This is not the examples from that semi-Pinacolone rearrangement, because you see that two adjacent carbon atoms OH is there. Okay, so this is the example of Pinacolone rearrangement. So you know that this, here we have the protonations, here we have that OH is there, and here we have that hydrogens, and here we have that hydrogen. So what will happen, that hydride shift will occur. So what we will get now, this is going to be hydride shifts, then okay, so this is going to be the CH2, and this is going to be the OH, this is going to the positive charge. So after that, this lone pair will give electrons, so we will get this one, that is going to be the CO and H. Okay, so fine. So that is going to C, and this is going to double bond O, this is H is there, here we have that H. So because one is do protonation, so this is only one H. Okay, so this is, then this is going to leave, and this is the product for this questions if it is H plus is there. Okay, now if TSCl is there, on that case what will happen, if this is there, on that case this will not go for this case, pyridine is there, so this pyridine, for this case it will attack to this one, means it obstruct the proton, this is the base, this obstruct the base, it will not obstruct this base. Okay, it will obstruct this big base, because for TSCl and pyridine, the rate of reaction is 1 degree, then 2 degree, then 3 degree. So it will do this, because this is the 1 degree 1 degree OH group is there. Okay, and this is the 3 this is the 3 degree. So it will, first preference will be the this one. So what will get here now? What will get? So this is going to be, this will not, it will not take base proton from here, it will take base from here. So this is going to be O minus. Okay, so now what will happen, that TSCl is there, so this is attack here and this is going to leave this one. So then what we'll get, then we have here OH, and this is going to be that CH2, and this is that OTS. Okay, and what we know, that this OTS is a good leaving group, this is a good leaving group, so this will leave, it means that what we'll get here, so this is going to be OH and this is going to be the CH2 positive charge. Okay, now what will happen, this is the positive charge, so after that what will happen, that it will do the ring expansions. Yes, so this is 1 2 3 4 5 6 and 7, because ring expansion is there, so we can do the ring expansions. Okay, so if you do the ring expansion, then it is positive, then here I will make, because I want to make this bond, and this is going to positive, and positive that will break the bond, so this bond will break, so what will get, this bond. Okay, and name that, this is 1 and 3, this is 4 5 6 7, and this is 2, so 2 is getting positive charge. Okay, and 3 1 3 4 6 and 4, they have the bonds 6 and 4. Okay, and 2, it has the OH is there, and yes, 2 has the OH. So now what will happen, this is the positive charge is there, so this positive charge and this lone pair will give electrons, then what will get, okay, so this is going to be let's say 1 3 4 5 6 7 and 2, and 6 and 4 we have this one, and 2 it will be like this. So this is the final product for this question. So whenever you're solving the questions, check the options also. So today after this, in the next class we will discuss about of that stereochemistry, that is very important stereochemistry, questions related to Pinacolone rearrangement, and also from semi-Pinacolone rearrangements, that we will discuss in the next class. Today after this, thank you.